Today we're learning about specific heat, which is on page 533 of the Modern Chemistry book. As you figured out, heat has a lot to do with a change in temperature, a transfer of motion from one chemical to another because of a difference in temperature, from the hot one to the cold one, from the one that's moving faster to the one that's moving slower. But the math equation that you've seen, Q equals m delta C Cp, is not just change in temperature, the delta T. It's also has to do with the mass, because if you have a heavier object, it takes more heat to change the temperature, and also has to do with the specific heat, which is for each chemical. Here's an example of that. Would you rather touch 100 degrees Celsius water or metal, and why? Why don't you pause the video and tell your partner what you think? 100 degrees Celsius is about 212 Fahrenheit, so boiling water, or oven that's not very hot. 200 is a lower temperature than you cook most things in the oven. So I would rather touch the metal, especially if my oven was only 212. I would definitely rather touch the inside of my oven, like the oven rack or the side of the oven, than to touch some boiling water. And that's because the boiling water would burn me worse, and that's because the water has more heat in it, even at the same temperature. It's not because the water's denser. It probably isn't. It's because the water has a much higher specific heat. So that means that to heat up water, it takes a lot more energy, so by the time the water gets to boiling, it has way more energy than a piece of metal. I managed to write over there just a second. Okay, so there's a definition of specific heat. It's the energy needed to increase the temperature of 1 gram of something by 1 degree Celsius. And the point is that different chemicals have different specific heats. They take different amounts of energy to increase the temperature of 1 gram by 1 degree Celsius. So water takes more energy to increase its temperature. Temperature is the average kinetic energy because of its strong intermolecular forces. So it has more energy to burn you with. Should probably pause the video and give people time to write that one down. So I say C sub S, some books say C sub S, I think your book says C sub P, some people just say C. It's all specific heat, the energy to raise 1 gram of something by 1 degree Celsius. The P means it's at constant pressure. So the specific heat of water is 4.18 joules per gram degree Celsius. In contrast, specific heat of lead, which I'll try to show you a demo for tomorrow, is 0.13 joules per gram degree Celsius. That's about 40 times less. So that means at the same temperature, lead has about 40 times less heat that it can transfer to you. Iron, like the inside of your oven is steel, probably. Iron is 0.4 about, so it's still about 10 times less. So the equation is heat equals mass times the specific heat times the change in temperature. For your calculations, change in temperature is really the only tricky part. It has an equation for it also. Change in temperature is temperature final minus temperature initial, the final temperature minus the initial temperature. So this is the equation we're going to use for calculating heat, or if we have heat, for calculating one of the other variables. Okay, the example I'm going to do is about as hard as they get. That's the reason I'm showing you that one, is because it's still not hard. So for example, if 50 grams of water at 20 degrees Celsius are heated by adding 200 joules of heat, what is the final temperature? So I guess pause and write that one down. You might hear Timmy in the background making cooing noises. He just woke up. He's pretty happy. You want to say something, Timmy? says ngu. Okay, so in our equation, we're going to solve for delta T, because delta T has the final temperature in it. So I can rearrange this equation. This is an important thing to know how to do from math class, but you're probably not used to having so many letters in your equation that you rearrange. You could rearrange it at the end. That might make it more similar to math class. I like rearranging it first, so I don't mess up on the rearranging part with numbers and units and stuff. So if we want delta T all by itself, it's not by itself. And the second baby says, Daddy. So I think I was saying that delta T is not by itself because it's being multiplied by M and C. So I'm going to do the opposite of that. I'm going to divide. Opposite of multiplying is dividing to cancel out. I'm going to divide both sides by M and C. So this side is going to be Q divided by M and C. This side, when you divide by M and C, these two cancel out and you're left with delta T. Okay, so we get delta T is Q over MC. And then you plug in the numbers that are given to you in the problem. Heat is in joules. Cough, cough, Timmy. And grams is for mass, and the specific heat of water would be given to you in the problem. It's also on the back of your periodic tables, like you usually use for tests. Specific heat is in joules per gram Celsius. In your book, it's joules per gram Kelvin. That's the same thing because the temperature is change in temperature, and Celsius is the same size of unit as Kelvin. So you can just substitute in Celsius for Kelvin, but you have to use Celsius or Kelvin, not Fahrenheit. Okay, so the change in temperature is 0.96 degrees Celsius, but we're not done with the problem. That's the change in temperature. So then just write the equation for change in temperature, final minus initial temperature. And we're solving for final temperature. So similar to how I showed you the algebra before, we want final temperature all by itself. It's not by itself because it's being subtracted by temperature initial. So we're going to do the opposite. We're going to add temperature initial on both sides. So we get negative temperature initial plus temperature initial over here, that's 0. And change in temperature plus temperature initial over here. So we're going to take our initial temperature given to us in the problem 20 and add 0.96. So you get 20.96 as your final answer. When you do the heat calculations, if there's any specific heats that aren't given to you on that, then you can find out on page 533 in your book.